Ian runs an energy consultancy company, High Energy, based in the UK, and he acts as a business development director for companies finding their initial business in Europe and the UK. High Energy brings sector expertise to bear in various EU-funded projects, such as Seafuel and GenCom, and prepares proposals for consortia, such as the first ever Hydrogen Valley project funded by the Fuel Cell Hydrogen Joint European Heaven project. The company expanded its operations to the Netherlands last year. Ian has over 30 years' experience in industrial gases, primarily in the hydrogen energy sector, having worked for Air Products. He's also been CEO of one of the few British fuel cell companies, AFC Energy, and he has a wide-ranging hydrogen supply and application expertise. Finally, Ian has been president of the European Hydrogen Association for the last 10 years. Ian, there's no better introduction than that, and over to yourself.
I'm going to have to start paying you, Paul, I think. Anyway, good morning, everyone. Thanks for the opportunity to speak to you today. Paul has stolen all my thunder on the first slide, so I won't go through that in any particular detail. But I'll just add one of the other projects that we've just started working with is a project called Green Highland. We wrote that together with NSC and another small UK SME. And we were lucky enough to win the finance for the project, which will be based on Mallorca. So yet another island-related project, which will look at renewables and how hydrogen can interact with those renewables going forward. So in terms of aviation, I suppose, why is this important? Why are we really looking at this particular moment? So you've got the EU and you've got national governments all making their commitments to the Paris Agreement, which shows that they need to decarbonize most of their energy systems by 2050. And if we look at air transport plays a role in, or a contributing role to those CO2 emissions, and is quite significant in terms of the mobility portion of all of our CO2 emissions. So governments cannot achieve their goals under Paris without doing something about air transport. I know we've all done our bit in recent times through not being able to go anywhere anyway through this pandemic, but we do expect to be able to travel, hopefully again in the summer, and we will see these emissions once again grow. So what options do we have? What sustainable fuels are coming? I think there are two normal carbon-based opportunities or carbon-based fuels going forward. One is synthetic fuels. So in a synthetic fuel, what you're using is you have a green source of the CO2. That could come from biofuels themselves, or it could come from even the atmosphere, collecting CO2 out of the atmosphere. Or it could indeed be a waste. So you've got CO2, you try and combine that with green hydrogen in a production plant, and you synthetically make the carbon-based fuel that we historically have had available to us through fossil-based solutions. That's one route. Another route is to use the biofuels directly in air transport themselves. And going forward, that could be something that looks like crops or algae, or even, again, waste oils being used to actually produce that fuel going forward. And I think the application of that into air transport is possible, but it's not one that we see as being completely viable in the longer term, because, to be honest, there just will not be enough biofuel going forward. The other issue we have is obviously that even though we have produced the fuel in a green way, we still emit CO2 at that particular point of use. And that's something which governments are trying to get away from. So the question has always been asked, well, what can hydrogen do in this particular context? And we've used hydrogen in transport for ages, and I could have put a picture up here of an airship, but that's a bit emotive and probably a bit more removed in terms of time to how we would deploy hydrogen today. What we're looking at is, we all know and love the fact that we've been able to go into space using hydrogen. How do we deploy that hydrogen experience and technology in a slightly different way so that we can actually use it for air travel? And what we're seeing is that we're not going to all end up in a rocket, much as Elon Musk would really like us to. What we're going to do is we're going to deploy those hydrogen molecules to systems that we have talked about already on this presentation, the likes of fuel cells and potentially the likes of hydrogen turbines going forward. So we understand that technology can be adapted, and that we have the experience and the expertise to do that. The other element of that is how we get those hydrogen molecules to those aircraft going forward, and we need a large-scale infrastructure change going to understand how that progress can be made for aviation. Added to that, we probably also got this opportunity for the bio-based and the waste carbon-related fuels as well, because hydrogen probably will not encompass everything, just like it won't in terms of land-based or marine transport. It won't be a one-size-fits-all. There's likely to be multiple fuels going forward. But what we understand and what we've seen in recent times, particularly in the last probably 12 to 18 months, we know that proofs of concepts are coming forward. We see those actually operating today, and we'll talk a little bit about some of those later on. And we're also seeing companies like Airbus take a position in this going forward. So if we can get the technology to work, then the next question really is, can we afford it? And when we look at these costs as to how hydrogen can participate over a long period, we've got to look at it on a like-for-like basis. In other words, the technology needs to be mature to be able to compare it to what we do today in terms of fossil fuels. And if we look at syn fuel versus liquid hydrogen, and yes, it is liquid hydrogen that we're talking about putting on the bigger aircraft, we see that the cost of the liquid hydrogen approaches that of kerosene. It will never get to be quite as low as we currently enjoy, but we do get to that particular position of approaching it, and therefore it becomes a position that we can afford going forward. So where do we start? I mean, I think the key here is all of the elements of an if you look at an aircraft, it's a very complicated piece of equipment. We have to break that one system down into its components and provide a series of coordinated steps to understand how the whole can be actually changed in terms of its vehicle fuel, or its running fuel. So we'll look at turbines, we'll look at fuel cells, we'll look at liquid hydrogen tanks, we'll look at lightweighting some of those systems so that we can get them off the ground. We'll look at infrastructure on the ground to actually understand how we can get the aircraft refueled in the longer term. And we'll also have to look at the codes and standards that we employ to allow those aircraft and those airports to operate in a safe manner. So it's likely that we're going to take a progressive route to this, and that smaller aircraft will occur first, or the change will occur in smaller aircraft first. We'll follow that by commuter prototypes, and that point will probably test the liquid hydrogen infrastructure. And then we're going to look at the longer range aircraft, and that may involve, as I say, this alternative fuel. So if we look at smaller aircraft, and there's not much of a smaller aircraft than a drone, we see that hydrogen has already made an impact into the drone market, in looking particularly in terms of military applications, but also in terms of how those applications have then found their way into a commercial world. So we see hydrogen-related drones being used in agriculture, and we see them being used for remote deliveries of essential items and medical supplies. And we see that hydrogen enhances the length of time that these drones can operate. It's exactly the same argument that we traditionally use within both land and water-based applications. And we've seen in the last 10 years, as these drones have been developed, you know, the flight times of certain hydrogen drones are of the order of days rather than of the order of hours. We're migrating that now into smaller passenger aircraft, and I think many have probably heard of a company called Zero Avia. They've been making quite a lot of headway in terms of their development of a small passenger plane. They started off with a small 6-seater aircraft. They're participating in a project or leading a project called High Flyer, which will basically allow that aircraft and some slightly bigger aircraft to be developed and to fly over, let's say, a 300 nautical mile range, and that's going to be from the Isles of Orkney to mainland Scotland. So we see that these aircraft are in development. We see that their first prototypes are becoming successful, and that progress is being made on these smaller vehicles, the smaller aircraft. But what that's leading to is effectively a momentum within the sector. We're seeing over the last 18 months, multiple studies have occurred, both from the aviation sector, but also from the hydrogen sector, that have said hydrogen can come to sort out the sustainabilities of aviation. And that's led to companies such as Airbus and Boeing getting renewed interest in hydrogen. And Airbus indeed launching its Zero-E plans in the last 2 to 3 months. This involves the development of a whole range of hydrogen-powered aircraft, and as you can see, of different shapes and sizes, which will take a while to come to an airport near you. But if we don't start today, they won't be ready by, let's say, 2035 going forward. What this needs as well is a map as to how we make these progressions, and a long-term regional and global framework in terms of both policy and intent. So the EU has set that out in terms of the transition towards net zero by 2050. The world has agreed it via the transition that is signed in terms of the Paris Accord. So we have the building blocks from that. Now we just need to make the steps in terms of the actual technologies. One other project that I wouldn't mind mentioning is a project called Enable H2. It's a project that I'm part of through my role in the European Hydrogen Association. And it's doing the groundwork, I would say, in terms of developing some of this aviation technology. It's looking at how we can design an aircraft using different liquid hydrogen concept tanks, looking at how far those aircraft will fly, and looking at how you can run a turbine on hydrogen without getting the embrittlement of the components, for instance. And in the early part of the project, we developed this timeline, this view as to how aircraft could migrate towards hydrogen. To be honest, we think that the blue lines on the right-hand side are probably moving towards the left-hand side now, because the interest has stepped up significantly over the last couple of years. So what do aircraft look like going forward? Well, and how do we make this transition? So initially, we can bring hydrogen to bear within the cabin. We can look at the energy usage within the cabin and convert those to fuel cells. For very small aircraft, we can use fuel cells to power the engine. For regional aircraft, for slightly bigger aircraft, we use the hydrogen and liquid hydrogen to power hydrogen turbines to run the vehicle, to run the aircraft. And as I mentioned before, we look at the emissions legislation tightening so that companies and airports don't really have a choice. They have to make this migration going forward. So the initial aircraft will run on gaseous hydrogen. The bigger and more progressive aircraft, as we go down this timeline, will move to liquid hydrogen. What does it mean for airports? Well, an airport's going to look potentially quite different in the future. So I think the concepts that most people have is, if we're making this transition with smaller regional planes first, then we'll see regional airports become users of hydrogen, and potentially that opens up a different network of aircraft or airfields for people to use going forward. In fact, you know, in the UK, as you can see from that little graphic, you've got over 200 smaller airports which we don't really use very much today. So those airports could come back into service. They could be used in terms of hydrogen locations or hydrogen point-to-point locations for these smaller aircraft as an initial migration point. And if we look at remote and coastal communities, they tend to traditionally have some form of regional connection by the air, and we see that those airports could be also the ones that are for an area of focus for this initial change. Larger airports are going to look very different going forward, because we perceive that, you know, in a hydrogen interconnected world in the future, we're going to have hydrogen delivered by pipe to various locations, whether they be just industrial locations or even right the way through to your own house. But those pipes will deliver the hydrogen to the airport perimeters, and then we're going to have to transition that gaseous hydrogen into a fuel that we can use. So we'll see liquid hydrogen plants around bigger airports, and those hydrogen plants will initially supply, obviously, the requirements of the airport, but they could also spill their molecules into the surrounding regions, and so airports can become localized hubs for hydrogen production within regions going forward. Again, one of the things that we have to watch is that we're putting these hydrogen production units very close to high use, high transport locations, and so we do have to get the safety criteria right going forward. In order to do all that, we need significant amounts of money. It's a massive transition, just like it is for land-based and marine vehicles. Air transport is going to need the same level of support going forward. The key will be how we interconnect all of those opportunities. And we saw in the Green Deal that was put through by the EU just last month that airports are a centre of focus for them. They did commit many millions of euros towards airport transition. We'll see which airports begin to take up that opportunity when the results of those Green Deal proposals are announced in the next couple of months. But we're also seeing national governments begin to follow the EU's lead there. And we're seeing the French strategic plan for hydrogen have a very strong focus towards aviation. That's probably not a surprise, given that Airbus have their engine testing facilities in France. And I'm sure that putting those two things together will allow Airbus to move forward with their hydrogen turbines for their bigger jets. Even outside the EU, it's getting very difficult to say that from the UK perspective, but even outside the EU, the UK is looking at funding a 100-seater zero-emission jet by 2030. So we're seeing that all of these governments are putting in place transition funding to allow companies to begin to innovate using public money. So what's going to happen next? I believe that hydrogen is going to come to an airport in the EU, not in the not too distant future. I think that the regional and community remote airports are going to be at some of the forefronts of this technology change. We're seeing the first movers already positioning for this opportunity, and that governments are making funding available. So it's not the final call to get on board with all of this, but it's the first call for those hydrogen innovators to get on board. And if you want your community or your airport to be associated with some of these endeavors, now is the time to begin to make connections within the hydrogen space to allow yourselves to become part of projects. I think that's me done, Paul. Thank you very much for listening.
Ian, thank you very much indeed. Excellent presentation. We've seen the land, the sea, and the air, and that's different timelines as hydrogen is now, will be, and hopefully will get to. Quick couple of questions for you, Ian. Is you talked there about the hydrogen hubs and the EU Green Deal. How much of the air side traffic could be transformed to hydrogen before the planes, such as the cargo holding and all of that? Can you see that as a catalyst for growth in the airline side?
Oh yeah, definitely. I think that those, if you can, we've done demonstrations about buses, about baggage handling, about forklifts. All of those technologies, to be honest, are getting towards being commercial, and we can employ all of those technologies at an airport going forward. If we add to that the planes as well, we see a complete picture becoming developed. The key, as far as I'm concerned, is how you deliver the hydrogen to those applications, because the amount of hydrogen that we will require at let's say a large airport like Heathrow will be vast, especially when you also consider that it's in the middle of a community. And so you've got the impacts of safety, you've got the impacts of the local community. So airside is one thing, but we will also see these opportunities spill out from the airport into the local communities.
As you said during your presentation, the smaller aircraft seem to be transforming first. And there's a couple of slides, a couple of links there from Chris Jones as well. How important are those smaller aircraft for community connections, given that Aaron Moore is connected from Galway and the other end with the smaller planes? Is that a key step in connecting communities?
Yeah, of course it is. I mean, this is one of the opportunities, I think, for hydrogen. Again, we see them come along occasionally, that there are niches here which hydrogen can embed itself into and then act as a catalyst for the rest of the community. So we've seen that the volumes that are concerned within maritime for connecting island communities may be quite large, but the volumes for smaller passenger aircraft may be manageable to be produced locally. And that may galvanize the rest of the community towards a different sustainability future compared with what we've had in the past. And even if, I know I harp on about the bigger opportunities as well. Only last week, the region around Paris issued an expression of interest as to how companies and communities and organizations can get involved in transitioning all the Parisian airports to a hydrogen-centric future. And that involved the airside traffic as well as the jets, but also the communities around the airports too. So I see that operating on an island or a remote basis on a smaller scale, but it's just as important.
As you said, it's vital for that community link, not just the maritime link, but the air link for those communities to maintain their links is crucial. Taking you away from the air side now, one final question for you is, as we move forward in the hydrogen transition and we go down and looking at zero carbon as a destination, how critical is it to match market supply to an unknown demand in order to get over these initial hurdles to get momentum within the market?
Yeah, it's difficult. It's everybody uses this phrase chicken and egg, and it's very difficult to get around this, but you do get you have to have vision in terms of demand going forward. So understanding how hydrogen can play a role in the energy sector in general is a much more important question in terms of energy storage, etc. The demand can then come along for the individual markets a bit later. But if we can use energy storage as a way of increasing the amount of renewables that we have within our overall energy grid, it allows those mobility markets to then become an access. And that piece doesn't necessarily have to happen immediately, but it's there when the markets come along that we have a mechanism to fulfill or to supply the energy requirement. Those particular areas, the sustainability, the mobility areas, some of them are very hard to reach. And hydrogen is one of the only ways that we can actually get to them in order to decarbonize. And having those molecules available is key going forward.
One final question, Ian, is in a presentation last week, the Prime Minister of the UK, Boris Johnson, talked about putting a bet on hydrogen. That's okay if you're putting a big bet and it's a one-horse race. You talked earlier about different hybrid solutions. How many other options do you think are in that race within the UK hydrogen transition?
What do you mean, in terms of aviation fuels, or in terms of
in terms of the industry grasping the nettle and being able to then develop that low carbon sector so that it spills out to communities and to industry? And as Boris Johnson said, that big bet, it'd be interesting what the odds on that bet would be, given that it's a UK bet.
Yeah, but I think he's looking at that from the perspective that the world is moving towards hydrogen, and it's a safer bet than it was maybe 10 years ago to be able to say hydrogen is going to be part of this energy mix. I think that the understanding and the level of understanding is at such a level, it's got to such a point now that we all know that hydrogen will be in that mix. We just don't know exactly how it fits with all of the other solutions that we have within our armory to create a sustainable future. And, you know, we see this in terms of passenger vehicles. If you look at batteries, they've improved immensely, and we see car transport, individual passenger car transport, potentially going to be maybe battery dominated as opposed to hydrogen dominated. But there will still be a mix of those things and a meeting of those technologies, and it will be a blurred line in the middle where those technologies come together. I see that happening right the way across all of our mobility sectors. There will not be one single winner, but even with these sustainable aviation fuels that I talked about, you need to have green hydrogen as part of the technology that manufactures those particular sustainable fuels as well. So we have no choice. We have to make green hydrogen. It will play a role in so many different sustainable options that we have.
Ian, thank you once again. Excellent insight, and hopefully there's pieces there for everybody to pick up.